So we're going to look at a couple of different approaches. So the first approach we're going to look at works for 0, 1 boxes. Because for 0, 1 boxes, the standard deviation of the box can't be just anything. It actually is within some limited range, and we can make a worst case assumption. So once upon a time, bless you, we talked about the fact that if we look at the square of the SD of a 0, 1 box, so the SD of a 0, 1 box is equal to the square root of p times 1 minus p. This rings a bell, yes, now. Didn't 5 minutes ago, but now it does. OK, and so the SD squared is equal to p times 1 minus p, which is p minus p squared. And we could write that as minus p squared plus p if you want. And this is the equation of a parabola, right? OK, and because the leading coefficient is negative, it's a parabola that has a maximum, right? And as p goes between 0 and 1, this thing goes up and attains its maximum at a half. And what is that maximum? Can we plug in? It's a quarter, right? OK, right? OK, if we plug in a half, this is minus a half squared, which is minus a quarter, plus a half is a quarter. OK. And how do we know that the maximum is at a half? We could do 15 seconds of calculus, differentiate this. We get minus 2p plus 1 equals 0. OK, so p is equal to a half. It would be the stationary point. All right, OK, so if we have a 0, 1 box, the SD of the box, so what does this say about the SD of the box could be 0. The box could contain all 1s or could contain all 0s, in which case the SD of the box is 0. The SD of the box could be bigger than 0, but the biggest it could be is a half, which is what you get if you plug in a half here. You get the square root of a quarter, which is a half. All right? So we don't know what it is, but it can't be bigger than a half. So if we're drawing from a 0, 1 box, and we're looking at the sample percentage as an estimator of the population percentage, then we know that the standard error of that as an estimate, we know sort of how far off it's likely to be, isn't going to be any bigger typically than the finite population correction times a half divided by the square root of n, because this can't be bigger than a half. Does that make sense? So we're going to be off by some amount. It's a random amount. We can't say how big it is in any particular case unless we already knew what was in the box. But the amount by which it's likely to be off, in the worst case, the problem is I'm mixing likely and worst case. So if the worst possible things were in the box, then the amount by which it would be likely to be off would be like f times a half over root n. Okay. For other mix of things in the box, then the amount by which it's likely to be off is less than that. So far, so good? OK. So this is a worst case upper bound on the SD of the box. It works for 0, 1 boxes only. Right? It doesn't work if you have a general list of numbers in the box.